Here we review the influence of the biologically active supplement hydroplasma on the proliferative potential of cultured human mesenchymal stromal cells. The following parameters were assayed: cytotoxicity of the studied drug, cell population doubling time, cellular migration, cell cooperation, one healing assay, and secretory activity of the cell culture. Damage to the cell membranes and other cells structured by free oxygen radicals is one of the principal reasons for pathological processes that lead to various somatic diseases. The most common risk factors for oxidative stress are chronic stress and fatigue, alcohol and tobacco use, and exposure to UV radiation, and environmental air pollution. Lately, there has been a significant increase in interest in herbal, natural drugs as they are safer and more adjusted to human physiology. One of the most common natural compounds are bioflavonoids, the largest class of plant polyphenols. Among the numerous biological supplements with bioflavonoids, we can single out the so-called hydroplasma. According to the manufacturer, hydroplasma is a concentrate for the preparation of biogenic water, which increases the degree of biological activity of any fluid, streamlining its structure, creating the effect of structuring bioplasm with energy-intensive biogenic memory of living water. The influence of hydroplasma on the proliferative potential of human mesenchymal stromal cells culture was studied using a commercial human hMSCs cell line. Cell mass growth was conducted according to the manufacturer's recommendation using the growth medium intended for hMSCs cultivation. The test products, absolute energy hydroplasma and water for life hydroplasma, were diluted in a growth medium according to the instructions to be various concentration. For AE hydroplasma, a maximum dilution was included in the study. To estimate the proliferative potential, cell culture was subcultured under 6-well plates. The studied drugs were added to different concentration and cultivated during 5 days. Upon completion of cultivation, cells were removed from the plastic surface and calculation with cell volume assessment. Then they calculated the time of cell population doubling. The wound healing assay method was used to study cell migration and cell cooperation. Further, cell culture was cultivated until a single layer formation was formed. Next, a marker was made using a sterile cellular pipette tip. Then the studied drugs were added to the culture medium, and the changes were then visualized under a microscope. To assess the secretory activity at the end of the proliferative potential experiments, human hMSCs culture medium was examined. After obtaining samples of the conditioned medium, the secretory activity of cells in the culture medium was evaluated using the vector-based ELISA kits according to the manufacturer's method. In our visual assessments of toxicity of the wall, the drug were not observed. Cells grow well in the presence of the drug. During so-cultivated waste wall, the control group had an advanced growth rate on day 3rd. There were no visual difference between the dilutions. In this regards, it was decided to continue further experiment with the X1 dilution. When assessing the cell culture group with the AE drug in different dilutions, the cultured hMSCs died. This was probably due to the presence of active photodynamic components having blue-greenish tint in the drug composition. When using the maximum dilution of the AE drug, no toxic effect on cells was observed. During the study of the cell's proliferative activity, the dynamics of growth of experimental and control hMSCs cells culture was similar. The time of cell number doubling for the hMSCs control group was 55 hours, which corresponds to the literal data. Then cultivating cells in media containing the wall drug D was 56 hours, because no valuable cells were found in the cell culture of hMSCs cultivated in the medium containing AE drug in standard concentration. The cell population doubling time was not calculated. With AE in maximum dilution, the proliferation rate of hMSCs cells was 60 hours. There was no statistically significant difference between the control cells culture and cells culture in medium containing wall, which presupposes the same rate of cells culture proliferation. To visually demonstrate the proliferative activity of hMSCs cells culture, the wound heming assay was conducted, which assessed cellular migration and cell cooperation. The control cells were actively migrating and completely overlapped the defect on the single layer formation. For the hMSCs that were cultivated in the medium containing wall, the cells overlapped the defect by 18%, as well as in the medium with the addition of AE at a maximum dilution. Complete overlap on the defect was observed 24 hours after the start of the experiment. Then cultivated in a medium containing AE hydroplasma at a concentration of X1, the cells did not migrate. Single dead cells were observed in the growth medium. The secretory activity of hMSCs cultivated in a medium containing wall or AE at extremely low concentration is comparably with the control well. The level of secretion by TNF-alpha cells was slightly higher. No statistically significant differences were found. The secretory activity of interleukin-6 and 8 in hMSCs cultivated in a medium with the addition of EA at normal concentration was 5 times lower. Cells did not secrete TNF-alpha, and the secretion of interleukin-10 was 2-3 times higher. Apparently, this was due to early cell death. In this study, two types of hydroplasma were analyzed, wall and AE. Each type was analyzed under 3 different concentrations, and each analysis was repeated 3 times. The average value and standard deviation were calculated from the data obtained. When assessing the overall effect of wall and AE hydroplasma at extremely low concentration on the proliferative and secretory activity of hMSCs, no statistically significant difference were found compared to the hMSCs control culture. When estimating the total impact of AE hydroplasma, the death of individual hMSCs was observed from the first day of cultivation. By the 5th day after the beginning of the experiment, all of the cells were dead. It was associated with a low content of TNF-alpha and interleukin-6 and 8 in the conditional medium, as well as a minor increase in the amount of interleukin-10. Thank you.